Hi everyone, my name is Venkatesh. I am from St. Peter's Engineering College as assistant professor. So today I am going to discuss about the topic is VLSI Design Flow. So VLSI Design Flow is very important when we want to implement the real-time applications of IoT process and AI process and whatnot, everything as electronic gadgets. As you know, right? So do you have guess? So one small chip is as a processor of the mobile phone. So when you see that VLSI, when VLSI is nothing but is a process or a technology to implement integrated circuits, ICs. So before VLSI, there were the different technologies are there, which are nothing but SSI, small scale integration, and next one is medium scale integration, and next one is a large scale integration, and next one is VLSI. So when we discuss about the small scale integration, here that when you can implement any device which is nothing but a gates or a processor or a microprocessor or microcontrollers, so we have to use different types of devices with the help of transistors. So when you want to be combine 1 to 10 transistors to implement one type of gate, which is called as logic gates. So with the help of the small scale integration is possible. Like which gates, which are nothing but AND gates, OR gates, all other logic gates. So when we want to implement the complex than the logic gates, which is nothing but multiplexers, adders, we can prefer that MSI. The next technology which is more larger than the SSI. And here the 10 to 100 transistors, we need to combine, it forms as one complex circuits. So applications of this MSI is the complex than the logic gates, which are nothing but multiplexers, adders, like this. So when you want to be implement complex circuits which are nothing but processors or RAMs, we can go to the LSI. LSI is a large scale integration. Here we can combine 100 to 10,000 transistors placing on the one single chip. So the applications of this LSI is, which is microprocessors and microcontrollers and memories. So for all this, if you want to implement, we can use that LSI technology. So now in our microprocessor and microcontrollers, so these devices may not be used in the computers or smartphones or laptops. So when you have to implement the smartphone process or a laptop process, we can choose that so high-end process, high-performance process, and it can it has only consume less power. So in order to do that, we have to go for the next technology, which is called as LSI. Here, billions of transistors placing on the chip. So this is called as VLSI. The real-time application is general processing units and graphical processor units, and all smartphones and laptops and all electronic devices. So when you can implement the VLSI technology, we should know how an idea should be converted to the one chip. So what is the process? What is the procedure we required to implement or to convert idea into that physical device? So here we can go to that. There is a VLSI design flow. So here we need to follow some steps. As you know, right, when you can construct a house, we require some steps. So here also, when you can implement a physical chip, we can go to the different steps. So first one is, so this is called as VLSI design flow or VLSI design procedure. So we need to follow some steps. It will convert into that idea into chip, which is nothing but physical chip. So what you have seen, which is nothing but our smartphone device chip. So this is how to convert one small idea into that fabrication chip. We need to follow some steps. The first one is, we require the design specifications. It has some different steps, design specifications. And next one is, and second one is design architecture. And third one is RTL implementation using HDL. This is very important. when you want to be implement any chip using HDLs. And next one is RTL verification. RTL verification is also very, very important. Even if you want to know whether the device is working properly or not, this is done by the HVLs, hardware verification languages. And the fifth one is synthesis. And this is a process to convert to the hardware code into that logical gates. Next one is physical design. And in this physical design, we have to do the 3 steps. Next, first one is floor planning. And next one is placement. And third one is routing. So these are all the steps we'll discuss one by one. And the 7th one is fabrication. And the 8th one is testing. We will discuss one by one. So first we see that what is the design specification. Then we see the different steps which are going to explain. The first one, design specification. Its specification is nothing but a requirements. Specifications, nothing but requirements. Whenever you want to be design anything like a chip or a processor or a controller or any washing machine ICs. So what you do? You have to implement the what you required. So means this is called requirement. So suppose let I'm taking one example. I have to implement one processor. The processor requires some parameters. What are the parameters? So means, so here we require the high speed processor, and it requires it has only less power, and it will be occupy only less area. So we consider all this. Let an example, but better understanding. So we have to go to that one AND gate. This is my logical AND gate. So this AND gate has some function which is nothing but multiplier function. So whenever we have to apply the different inputs, it can produce the multiplication of the inputs. Let's see that the AND application is the multiplication. So here I am taking that I required 2 input multiplication. So it requires we requires 2 inputs and 1 output. So as of now we discussed about that specifications of AND gates. So 2 inputs, we can give the 2 names, 2 variables. So which are variables are nothing but A and B, and 1 output which I discussed Y. These 3 are variables for the 2 input AND gate. So if you require the other design, the specification will be different. For every design it has a specific features are there, specific requirements are there. So for every design it has a special features are there. So here I am giving that 2 input AND gates. Let's come to that. Second one is design architecture. Design architecture. This architecture will be generating by the experts in the VLSI technology who are having the more knowledge, who are having the more experience. They only will decide that what is the structure, what is the design architecture they will be proposed. As per that proposed design architecture, the developer will implement the code for the design. So this has, for example, 2 input example, we have AND gate, we have only 2 inputs, right? This has the 2 inputs A, B, and produce 1 output. So as you know, right? So Y equal to multiplication of A into B. You must know about that. So output of the Y. What is Y? Y is nothing but function of input A comma B. Here the function is nothing but multiplication function. So let's say I am given that truth table of the multiplier. It has 2 inputs and it has 1 output. So that's why it has 2 inputs. It produce the 2 power 2 means 4 combinations. That's why here 0, 0, 1 combination, 0, 1 is 1 combination, 1, 0 is 1 combination, 1, 1 is 1 combination. when you can pass the 0, 0 inputs to the design, it can produce the 0 as the output. That's why here 0 into 0 is nothing but 0. So when you can pass the 0 into 1 is nothing but 0. So 1 into 0 is nothing but 0. 1 into 1 is nothing but 1. So these things we have to be right in that output expression. This is 1, right? So that's why y equal to a into b. So this is nothing but a and b. So this is nothing but a architecture of the design for your 2 input AND gate. Let's comes to that. The second, third parameter or third step is RTL design. RTN design implementation using HDL. So what is HDL? Here that real thing is started. So you know, right? So what is HDL? How to implement that hardware design with the help of programming. So you must think about, as you know, right, C and Java. These languages are very helpful if you want to implement the software. So the same, similarly, here also the HDLs are help to implement the logical behavior of the circuits. So you have decided what type of design you want to be implement, what type of IC you want to implement. That design you have to specify, your design, your architecture you have specified already. So then you will go with that idea is implemented in the form of coding. So here the HDL is nothing but hardware description language. Hardware description language. This is very, very important when you can implement the chips. HDLs, so hardware description languages. So this means it can describe the hardware by using hardware, describe the hardware or a design by using hardware description language. So whenever we want to be implement any type of circuit behavior, any type of hardware designs, so we must remember that we must know about what is a behavior. So how to define that behavior, how to describe the behavior. So here that, so the describe the behavior can be done by the multiple ways in the form of coding, which are nothing but, the first one is, we can choose multiple ways to implement the behavior of a circuit. The first one is gate level modeling. Next one is data flow modeling, and third one is behavior modeling, and the fourth one is structural modeling, and the fifth one is switch level modeling. So these are the different ways you can describe the hardware with respect to the logic gates, with respect to the transistors, with respect to the operators and operands, with respect to the high level behavior, with respect to the small blocks will be used to implement the larger blocks. Everything we can implement with the help of the different modeling techniques are there. So let's come with next one is how to write. So the AND gate programming in HDL. AND program in HDL. So there are the multiple HDLs are there. Hardware description languages. First one is VHDL. This stands for very high speed integrated circuit hardware description language. It was the first language for describe the hardware. Next language was Verilog HDL. So this is very familiar programming language which is used in daily case, and most of the countries also use the Verilog HDL to describe the hardware. And next one is, these are the HDLs. So coming to Verilog HDL, it is from the C language. So when you know about the C language, we can implement the Verilog HDL very easily, because the most of the syntax which is comes from the C language only. So let's comes to that, to input AND gate programming using Verilog module. So whenever you want to be start with the C programming, everything is we start with functions. Here also, so whenever you want to implement the HDLs programming, so everything is starts from the module. Next one we can give the module name, and next one is we have defined the inputs and output ports. So here that's why ports list, we can say that ports list, and every statement must end with semicolon, and then we can declare the which are input ports. This is called input port declaration. And next one is output port declaration. So next one is, so once we have declared the input port and output port, let's come with next one is function declaration. It's very, very important. You can choose any one of the modeling out of the 5 modelings. Let's come with function declaration. And sometimes it is possible to, you may use task or functions. It's same like a C programming functions. Here also we can use the task or functions. So at the end, finally, the module can be terminated with the end module. So you must remember that when you can write the HDLs, so every program starts with module and terminated with the end module. So in between, we have to place that ports declaration, output declaration, and also the function declaration. If you require any task or functions, you can be declared over here. So next one, we can start with the AND gate programming in Verilog. So as you know, right, AND gate has 2 inputs, A, B, and Y. So what is Y? Y is nothing but A into B. So there is this function can be implement any of the modeling, any one of the modeling. We have 5 modelings. So first one is gate level modeling. So this is the modeling is nothing but you can describe the functionality in the form of logic gates only. That means if you can describe any functionality in the gate level modeling only in the logic gates. So as you know, there are the total 7 gates are there in the digital logic circuits, which are can be defined the logic behavior of circuits. So the 7 gates are, the first one is out of 7 gates, so 3 are basic gates and 2 are special gates and 2 are universal gates. So every gate has some predefined primitives are available in the language itself. That's why if you want to be implement basic gates means, so first one is AND gate, second one is OR gate, and third one is NOT gate. So for special gates, XOR and XNOR gates are used as a special gates for comparison purpose, for checking the parity. So when you go to that, next 2 cases are universal gates, which are nothing but NAND gates and NOR gates. These gates only will be used in the fabrication of the ICs. So let's come with universal gates. We can use the NAND and the NOR. So there is some syntax is there. We need to follow that when you can use the gate level modeling. The syntax is means, so gate label name followed by outputs comma input ports, and next one we can put the semicolon. So we should follow the syntax, then only you can write the gate level modeling. So let's come with gate level modeling. If I have the gate is, suppose I want to implement that AND gate. So first one is AND, we can write AND, gate label name is A1, and your wish this label name is nothing but there are the multiple gates are there in the circuit. So how we can differentiate the circuit with the help of some name? So that is called gate label name. So when you come to that gate label name, so here that one, next one is the output followed to the inputs. The output is Y, the followed to the 2 inputs are A comma B. So this is a syntax you can apply to the remaining gates also. Suppose when I want to be implement XOR gate, what I do? So here the XOR is gate, the X1 is the label name, and the output Y and the inputs are A comma B. So always you should remember that Y is followed to the inputs A and B. So this is the syntax we need to follow when you want to implement the logical circuit with help of gate level modeling. So then comes to the programming of 2 input AND gate with the help of gate level modeling. I choose gate level modeling module. Module name is simply as a AND gate. So we can give the proper module name AND2. So we cannot give directly AND because of AND is a primitive. Don't give as a module name. And next one is it has a 1 output Y and 2 inputs A comma B. So after that, what you do, out of three variables are 3 ports list, which are inputs, which are outputs. So then comes to that. So then we can declare the input A comma B. This is called as input declaration. And next one is output Y. So after that, I have to use any modelings which are nothing but gate level in data flow. I choose here right now as a gate level modeling. That's why. So which gate we are using for AND gate is simply as AND gate directly is available, right? Then comes to here A, B and Y. That's why I just use the AND. Something label name is A1 and the Y is output A comma B. These are the inputs. So you always remember that every statement is terminated with the semicolon. And finally, at the end of this one is we can terminate with the end module. There is no space between the end and module. It is a one keyword. So keywords are very, very important. When you can implement any programming, keywords has a special meaning. It has a reserved in the programming language itself. So don't use the keywords as the identifiers or something variable names. You should prefer that keywords whenever it is required. It has to be highlighted automatically. So then comes to the next one is fourth step is design verification. Some other times it is called as or RTL verification. What is RTL? So this is RTL. Most of the times we heard about RTL. RTL means how data is flows from one register to the other register. So when you say that it is the one register, this is the one register, the data is entered into the registers and this data will be transferred to other register. So this how data is flows between the registers. This is register 1, this is register 2. So how data is flows between the registers, it is called as register transfer language. So when you go to the fourth step is the design verification, means up to now you have done 3 steps. The steps are, first one is design specification, design architecture, third one is nothing but a RTL design using HDLs. So at the time of verification means in the verification we have to decide whether your design is working properly or not. You should know the correctness of the design, whether it's working properly or not. How do you know that? We can apply the testing inputs and check the design and you get the response, whether the response is as you expected or not. That thing we have to verify with the help of the RTL verification. This verification is nothing but checking the correctness of the design using HVLs. This HVL is nothing but a hardware verification language. This language is used to verify the design. So most of the real-time engineers in the VLSI, if 30% of the members are engineers are working in the design team and 70 members are working in the verification team, because of when you know that when you know, so verification is more important than the design, because of if verification is not done properly, what is happening? If maybe the device or a chip may release it to the market, if design or chip is maybe fail after releasing the market, that can affect the huge impacting on the company brands. So that's why in order to verify the proper design, you must choose the proper skilled verification engineers. That's why HVL is very important. Here we can choose the proper language also. That languages are nothing but SV, system Verilog, and next one is UVM methodology. So right now the UVM methodology is more familiar thing, and we can use the UVM methodology, so which can verify the design. Even the complexity is also going to be increased. So the SV is nothing but it is the language system Verilog, which comes from the Verilog plus OOPS concepts. So UVM is nothing but methodology. It is based on the SV. And next come to that here. And fifth one is synthesis. What is synthesis? After verification, after checking whether the design is working properly or not with the help of HCl, next one is synthesis. Synthesis is nothing but a process to convert into that hardware code into the netlist. So that means it is converts into that HDL code into netlist. This is netlist means this is the information is very important when you want to implement the physical design of the IC. So that means, so how many ICs are, how many gates are using, so how that gates are going to be connected, all this information are given in the netlist. This means net is nothing but a, here that gates, we talk about gates and all the wires and all the contents is given in the form of list wise. So that means hardware is converted into that, hardware code is to be converted into that netlist or a logic gates. Is simply called as in that simple words is nothing but logical gates. That means which type of gates you are using, what type of gates you are using, all this information you are given with the help of synthesis. It is a process done by the tool itself. Okay. So next one is, sixth one is physical designing. Physical designing. So this is a very important. Up to we have seen only we have defined the specifications and architecture and coding process and that verification synthesis process we have done. Let's come to the real scenario, so we can see the physical device and how to implement the physical device of that particular design. So I have taken the 2 input AND gate. So how to get the 2 input AND gate IC? I am not getting that behavior. I want to get that physical IC. I want to touch and I can feel it. So with the help of the physical design is possible. So here we can simply work on that silicon diarea. So we know the process of how to make the chips IC. On that IC, we have to choose the particular library setups, like we have to implement like 2 nanometer technology or 5 nanometer technology or 11 nanometer technology. We can choose any one of the technology. This is given by the standard cell library. So it is defined by the company tools. So once go to that physical design, here we have to remember that 3 points are very important. The first one is floor planning, and second one is placement, and third one is routing. So these are the very important. What is the floor planning, what is the placement, what is the routing? I will give you a simple analogy. When you want to be construct a house, so what do you think? So we have given some space, we have give some space that is in the form of square feet, right? So how to place that proper bedrooms, how to place the proper kitchen, how to place the proper puja room, all this. So we have to choose the proper planning. So whenever you want to be construct a house, similarly when you want to be implement any design on the IC, we have to choose where I have to be place the proper logic gates, where I have to place the proper CLB blocks, configuration logic blocks. All these we have to plan properly. So don't waste a space. Space is very important. That's why the floor planning is nothing but is very important. After that, placing of the planning of the floor, then you can decide how components has to be placed, then how the connections will be established on the logical blocks on this silicon area. So here these 3 points are very important. This is simply called as a PD, physical designing. And next come to that, once we have to implement the physical designing, then we can do the fabrication. What is the fabrication? So this fabrication is nothing but we want to be getting the physical chip, right? So this physical chip we have to implement with the help of fabrication units. The fabrication units are not there in India. So till now, so central government of India has announced they spent 40,000 crores to implement the semiconductor companies, so manufacturing units, so in all over India. So that's why in coming years in India also will start to the fabricating the chips, but till now we couldn't get any fabrication chips in India. So that's why a fabrication is nothing but some fab houses are going to the fabricate ICs. So So most of the chips comes from the Taiwan semiconductor company, manufacturing company, TSMC. So this is the step is very very important. As a real ICs we can see it. And next one is, once we have done the fabrication, then we can do the testing. So this is point is very very important. Once we have done all the steps we have done properly, we have to check again. Why? Because of if we can release without knowing the proper IC is working properly or not. So if you can release that into the market, if maybe fail, so that's the problem. So there are the we can remove the faulty chips. This is the process. We can remove the faulty chips. So only it can allows the correctness of the chips. Correct chips will be released into the market. This point is very very important. So these are the points we discussed still now. There are the multiple steps are involved to design any chip, and the main important is when you want to be implement any kind of design. So you should remember that there are the 2 points I remember. The one is the means VLSI chips are VLSI design flow has 2 parts. The first one is front end, and second one is back end. In the front end, we done the multiple steps like design specifications, design architecture, RTL implementation using HDLs, and next one is RTL verification using HVLs, and finally we have done the synthesis. So these are the steps we have done in the front end. And this is about all about the front end is nothing but we can define the behavior of circuit in the form of coding. And this means back end means here we can implement the physical ICs. That means the placement, floor planning, placement, routing, all this information is given, then finally fabrication. So means, so these 2 steps are very very important to implement the ICs. So first one is front end, second one is back end. As of now it is clear. I hope everyone is clear. Let's come with next one is types of VLSI chips. Let's see that. So here most of the chips are only 2 types. First one is ASIC chips, and next one is FPGA. So ASIC stands for application specific purpose integrated circuit. This means, so if we can implement one IC, that IC is only designed for specific application. It is not designed for multiple applications. So suppose let me give an example. If I want to implement design IC for washing machine. So if I implement, or if I want to implement or fabricate IC, that IC is only work for the washing machine purpose. It doesn't use it for the controlling of other applications. So see, this is nothing but a application specific purpose integrated circuit, and this is designed only for the specific application. It is not used for the multiple applications. Not designed for multiple applications like a traffic controller IC and all these washing machine ICs and ATM machine ICs only is limited only for one applications. So whenever the requirement is more, then you can use the ASIC ICs. So let's come to the second one is FPGA. This is field programmable gate array. That means it is a one of the IC which is reusable. So there is some space is there. Here there are the multiple blocks are involved. All these blocks are going to be connected properly, and these all inputs, all design inputs, nothing but programmable. This means reprogrammable device. So this is nothing but whenever the requirement is less, then we can use the FPGAs. This means the cost is very high when you can buy a field program ready. The cost is very low when you can buy a ASIC ICs. Because the FPGA is nothing but a predefined IC, it is a reusable IC. So whenever we can see that CROs in our academics, we can see the CROs, and also in military applications, because of wherever the requirement is low, so that you can spend the more amount, then that product's name is called as FPGA. So whenever the requirement is more, you can spend the less amount. That IC is nothing but ASIC. It is a reprogrammable device, means is a reusable device. So means, so once you have done one operation, before releasing into that, before implementation of ASIC IC, so they will not directly implement the ASIC ICs. They will be doing the same process of the design flow. After that, they will do that entire functionality verification on the FPGA. If FPGA has to be produce the proper output, then only they will decide that they will implement the ASIC. If the FPGA will produce the wrong result or any faulty result, they will stop the process, and again they will be modify the coding, and again they will be verify the proper design. So this is all about that FPGA. That's why FPGA is less usable, and it is a predefined IC. It is a reprogrammable device. And let's come to that. So I just want to be discuss about the different modelings in HDLs, Verilog HDL. Let's come with Verilog HDL. Is very important language which is used in the RTL designs. So here Verilog is from C language. From C language, the most of the syntax comes from the C language. So as of now, Verilog should follow some keywords. It has some keywords, very important, and it has some procedure, and it has some proper definitions, and it has proper syntax. We should follow it. And whenever it comes to the Verilog HDL, it's all about is nothing but 5 modelings. 1, 2, 3, 4, 5. So first one is gate level modeling, as already discussed in the given example. And second one is data flow modeling. And third one is behavior modeling. And fourth one is structural modeling. And fifth one is switch level modeling. So first of all, I would like to discuss about gate level modeling. I already told you. So for implementation of any design with the help of gate level modeling, we should follow the only gates. And the gates are nothing but 7 gates, already discussed. So let's come to the data flow modeling. This data flow modeling is nothing but how data flows between the logic gates. So here it describes the hardware by using operators and operands. Let's see that what is the operator. Let I give that one example, C equal to A plus B. So this is nothing but one statement. This statement is comprised of the some operators and operands. So C is nothing but one operand, A is nothing but one operand, B is nothing but one operand, which is nothing but variables. It can hold the values. So Let's see that equality and next one plus are nothing but operators. So if you want to implement the gate level modeling, you can use the only gates only, but if you can implement the data flow modeling, you can use only operators and operands. It forms as one statements. So for every descriptions of the hardware only in the form of the assignments. So the here data flow modeling, we can use that one more keyword is very important, which is called as assign keyword. So as of now, right, we discussed already AND gate. AND gate has functionality y equal to a and b. How we can implement this AND gate in the by using gate data flow modeling? So we can use the simply called as assign keyword, and the remaining is rest of this as it is y, a and b. This means so a and b perform the AND operation that could be assigned to the y with the help of assign keyword. This is called as the data flow modeling. Suppose if you want to implement the multiplier operation, if you want to implement the addition operation, all this only with the help of the operators. There are the multiple operators are involved. So you know, right, logical operators, arithmetic operators, and relational operators, unary operators, binary operators, ternary operators. All these operators will be help you whenever you want to implement data flow modeling. Let's come with next one is behavior modeling. This behavior modeling will be useful whenever you want to be describe hardware by using high level modeling. So here we can follow that loops, conditional statements. It is simply like a C programming. It is simply like a C programming model. Like we can use that different constructs also, like always, initial, and for loops, while loops, case statements, if else statements. All this we can use in the incorporate in the behavior modeling. And next one is structural modeling. The structural modeling is helpful structural modeling means we can construct the larger circuits with structural modeling. We can construct larger circuits with the help of small circuits. So this is nothing but a simply high level modeling. So most of the times when you want to implement high level modeling, which is nothing but if you want to implement a process, it has multiple components are there, like ALU and CU and memory. For all this, we have to implement again by the submodules. So we should follow that two approaches. One is top-down approaches, and second one is down to top, or this simply called as bottom to up. So we can follow any approach whenever you want to implement the structural modeling. Then comes to that, and last one is switch level modeling. The switch level modeling is nothing but describe the hardware by using transistors. As of now, even when you can implement any type of gates is nothing but as it consists of number of transistors. If you can describe your functionality or your behavior in the form of transistors, that modeling is called as switch level modeling. So here we can use the different types of switches like PMOS, NMOS, and CMOS, all this. With the help of these switches, we can implement any modeling, any design behavior. That modeling name is called as switch level modeling. So I hope everyone is clear up to now. Let's come with let's see there are some different examples using different modelings. I can give one example for today's lecture, which is multiplexer. A multiplexer is a data selector which has the multiple inputs and produce only one output, depends on selection line. So how to implement this type of multiplexer with the different modelings in Verilog HDL. So let's come with one data flow modeling. So first of all, before you go to that modelings of Verilog HDL, you should know about the what is syntax, what is the truth table. If s equal to 0, this means this A can, whenever the selection equal 0, the out of two inputs A can be forward to the output Y. That's why A can be at the output side. Suppose if s equal to 1, then the B can be transferred to the output Y. That means, so here the simple logical expression is y equal to s bar into A plus s into B, right? This can be implemented with the help of programming of Verilog HDL module mux 221 y comma A comma B. So out of, and you should remember that those selection lines also you have to be declared it A comma B comma S. Out of this one, out of 4, which are inputs means input A comma B are normal inputs, input S is selection input, and Y is output. So I just want to follow that behavior data flow modeling. Assign Y equal to, so S bar means negation S into and A. So plus means OR gate. So S into means AND gate. Then we can write the B. This is simply as a multiplexer to input AND gate using a data flow modeling. So thank you everyone. So the remaining class we will see in the next class.